Hi, my name is Frank Summerjay. I'm a Senior Program Manager with Azure Global Ecosystem.
And my name is John Doyle, and I'm a director within the Worldwide Health Industry team.
Today, we're going to talk about the Azure Security and Compliance Blueprint for HIPAA and High Trust Health, Data, and AI.
The blueprint is designed as a modular foundation to help organizations to ingest, store, analyze, and interact with sensitive and regulated health data while maintaining security, privacy, and compliance requirements. The blueprint also provides a number of core assets to include step-by-step documentation, a cybersecurity threat model and component reference architecture, a customer responsibility matrix, an external compliance report, deployment scripts to automate deployment, and a sample health dataset and machine learning experiment.
So let's take a look at what it takes to deploy the solution. We're going to take a look at it from our site administrator who's going to start the deployment process, and he's going to open up a PowerShell script and run a single command. This command will give him the ability to stand up the environment that we will be using throughout the solution. The deployment will set up users, will register resources, will ensure that the resources and the groups or assignments using role-based access management are set up correctly. We'll establish new users. These are the scenario users that you see throughout the solution in Active Directory. We'll also set up object IDs and establish a Key Vault instance for properly encrypting and securing the environment. At this point, now we'll deploy the resources in the Azure Resource Management. Next, we'll set up the machine learning. We'll deploy the machine learning experiment. We'll create a patient data schema. We'll encrypt the schema. And finally, enable Azure Security Center. Next, we're going to train the experiment. A data scientist will log in, and utilizing this CSV file with flat data, he will import the information. This includes sensitive and non-sensitive patient information. The sensitive information here we see is related to the first name, middle name, last name, and a bunch of additional other information associated with these patients. The hospital length of stay is the column that we're actually going to run the experiment against. Now let's import that 100,000 record CSV. We can see the security model being implemented when we log in as a SQL administrator and retrieve the patient data information, noticing the fact that the sensitive information was encrypted correctly. In our predicting the length of stay, we have an experiment, and this is the analyze phase of our project. Here you see the model that was created. It's a very simple model, but it will provide us the ability to train a machine learning environment. Now we're going to admit 10 new patients. The care line manager will run his script and admit these patients into the system, and will also store it securely. As you see, Chris, the care line manager, is now logging in. We will now insert 10 new records into the database. We now can go back into the SQL administrator to see the database. The records with the sensitive information is encrypted. And using these 10 new patients, now we see the machine learning results of the predicted length of stay associated with it. We want to be able to look at the predicted versus actual length of stay in our report sample. And here we see a Power BI dashboard giving us some insight onto the patients that were admitted. And it also, we can see the patient information with the actual length of stay that was recorded.
And in summary, the blueprint demonstrates how to design, build, and deploy an environment that protects sensitive and regulated health information.